Cool. Hello and welcome to our brand new session, Formatting for the Masses. To be honest, we did that last year. I just took the whole talk from last year and will do it in 10 minutes instead of in half an hour. So I will talk very fast. I will go through things. You don't have to understand everything because he's the star today. Because he will present his ideas about formatting for the masses, machine learning formatting, not the stuff I presented last year. But to make it a bit more exciting, I enhanced the demo. No applause, sorry. So it's Formatting for the Mass 2. So actually I'm Holger, that's Fabio. Hi. We are both working for itemis, so that's enough. Formatting. Who does not know what formatting is? Okay, that's good. It's about beautiful code. As I said, I will speak fast because we only have 10 minutes. So this is parsable but not readable. This one is readable and parsable, and that is what we want to end up with. Beautiful code. Beautiful code is formatted by using spaces, line breaks, indentations, and alignments. That's it. But we have to calculate where to put it, or we have to implement a formatter to do that. But there are several formatters for nearly all languages that we know. Yes, sure. And you can even buy it. Yeah, it's pretty expensive. I found that on the web, just to make a joke, sorry. So what's the point? Why do we need formatters? Because there are languages that you can create on your own. They are called domain-specific languages. And for that, there are no formatters out there. So, and formatting is a matter of taste. I mean, if you look at the example, that's natural formatting. The other one is the @merx formatting. He does it differently, and so it's a matter of taste how to do that, and people claim this is right, this is right. Yeah, that is why formatting frameworks have a lot of options. So JDT has a lot of options, gazillions of options. You can store that, put that into your project, but there is no option for everything. So what do you do when there's no option? You can just click on the enable off on tags with add formatter on and off, and then you can switch off the formatter, and within that you can do whatever you like. To be honest, I have never seen that before, just digging into the code and trying to find something that sounds weird. I found that. Okay, what is when there is no formatter? Like I said, for the domain-specific languages, you have to write a formatter, and that's the hardest program I've ever written. I mean, defining a formatter is very hard. Because of that, in Xtext, who does not know what Xtext is? Okay. Xtext provides a well-defined rich API for doing that, but even with that API, creating a formatter is still hard. So, and options are not coming for free. As you have seen in JDT, there are options that where you can switch things on and off and all that. You don't have that for DSL. You have to create it, and that's hard. Wouldn't it be cool if you don't have to implement a formatter? I mean, to be honest, I'm very lazy, so I don't want to write a formatter. And even when it comes to white space aware languages, that's hard. I mean, would it be cool if there's some magic doing the work for you? And we thought that's a good idea, and we looked into Google and we found something from the author of Untitled, that's Terence Barr, together with Jürgen Vignew. He's from the university near Amsterdam. And they both have written a paper about machine learning formatting, and they implemented something. And I would like to present to you Codebuff in a very tight way. So you will not really understand everything behind machine learning in that matter. But as I said, he's the star, not me. So what does Codebuff do? Very simple. It just mimics the developer that would normally do the formatting by its own. So what he does is, that's an invalid simplification of machine learning, of course. On the left-hand side, you have a vector with a lot of features, and at the end, a result that we want to pick. And we transform that vector in another one that we can apply to format something. And to make it more fancy, we tied Codebuff together with Xtext. So actually, that's an Xtext grammar. And what does Codebuff do? It picks a part of that grammar In this case, the grammar itself is the instance. That was confusing. I mean, the grammar in Xtext itself is a DSL. So we take the DSL for the grammar as an example. And what we do there is we have a parser rule. We have a lot of other things, but what we care about are the tokens. And after that, if we look at an instance of a DSL, we just have the keywords and white spaces and all that. And we look at that and we want to know where to have a line break and where we have indentations and all that. So we compute that. So we are aware about the tokens and we can see the white spaces. So what we do is we calculate the so-called token properties, and that is the vector that I explained. After that, we try to find out of the complete area of vectors which one fits best, and then we apply the result, I mean line breaks and indentation. So, and what do we care about? Spaces, line breaks, indentation, alignment, or nothing. So that is what we can apply. So that is what we get as a result. And so it's about new lines and spaces at the end, because indentation is nothing more than a space, but it is well defined in all places. So in our example here, we have a line break and we have 8 spaces. So that is what we apply, but we need to calculate that. How is that done? As I said, we calculate the token property, then we try to match that in the area where we have all the vectors already calculated, and then we get the result. What are the spaces to apply? What are the new lines to apply? And then we apply that to the new text. So first step is going through the tokens and calculate the vector. And for that we have a bunch of features that we use as an indicator. So we have the token itself, we have the previous token, because Codebuff is based on the grammar-based approach, because it's for Terence, and Terence is about the Untitled air, and so Codebuff is based on Untitled air. So we have a grammar, we know all that. And we know where is there a pair, or what is the parent nodes, because we are aware about the AST, so we have a lot of knowledge about the language itself. And that are our vectors. We have 21 features that we use to create that vector. And so we calculate from a hopefully huge amount of, yeah?
Can I ask questions during the part?
Maybe after my part, okay? Sorry. So we have 21 features, and we calculate those vectors, then we match that, get the white space and apply it. And for the first phase, we have to train that vectors, we have to train the metrics. And so we compute that for all the different areas, for all tokens, and we store that into a matrix so that we can then match other things against that matrix. So we have that calculated, and if we then have an unformatted document, we do the very same thing, calculate the token property, but we don't store it, and then we try to find the best match out of the matrix that is there. Then we apply that. And doing that is pretty simple. We do that with k nearest neighbor. To be honest, this is not really machine learning. That's the simplest approach you can use for machine learning, but it works. So what we do there is we use a vector. I mean, we pick 11. That's a number that Terence found out by experimenting. We pick the k nearest neighbors with a number 11, so 11 neighbors, and then we have a weight function to choose the one that is best, and we pick that and then we apply the white space. So pretty simple. And now it's a demo. So what I've done is, compared to last year, I tried to bring that together with Xtext. So what we have here is we have 2 plugins. They are available on GitHub. And the only thing that you have to do is you have to reference that plugin here in the manifest, Codebuff, in the runtime plugin of Eclipse Xtext, and in the UI. So same stuff. And then the only thing that you have to do is, in the workflow, maybe you're not familiar with that, but that's the code generator for generating the infrastructure for Xtext. And you have one fragment, and that's everything you have to do to make the magic happen. And when we then start runtime Eclipse, there will be exceptions. We need that, otherwise it doesn't work. No, to be honest, I don't know why, but there are exceptions. But it has nothing to do with Xtext. So what we have here is an example project, and there we have a folder named corpus. I just choose that name. You can name it however you like. And there we have an example. I just did that with one example. And there is no pre-calculated stuff. So we do that on demand. And we don't store that currently. So here is a well-defined example of the entity domain language that we have. And here's an unformatted example. And the only thing that I have to do, I have to press format, and then under the covers, it calculates the matrix, chooses the k nearest neighbors, applies that to the text, and you're done. And that's not pre-calculated. And that works for all languages. But I will skip doing that for a new language. You have to believe that that works. I mean, I can say something about the internals. Codebuff itself is an academic project, so it works for an example. But in addition, the API is horrible. And so that is why I had to do a lot to make that happen. So this code here, I'm not proud, will come to hell, I think. I have another class loader that I need to use because Xtext and Untitled F4, they don't want to be in the same universe. And there is no API, but there is Java, I can do everything through reflection. And I did that. So this is all reflection code for invoking things in Codebuff. Of course, this cannot be the answer. I mean, we have to change that API, but I just wanted to say, yeah, there is a way of doing that, but it's pretty ugly currently. Beside that, I did a lot to make that happen here. So there is something generated that is not on the class path, because if this is Untitled F4, that is doing magic in the back, and I just put that there, and then I throw that at the JIT compiler and compile all that stuff. I mean, that's magic. We don't want to do that normally in production. Just to let you know that the code that you will find on GitHub is pretty cool, but don't use that in production. Okay, let's come back to the slides. I will do that even more faster. So he found out that the best number for examples is 11. So after that, the results will not get better. So the error rates for those languages here are not better even when you choose 100 examples. So the only thing that you need is examples that are formatted in the same way. And of course, they have to have the full set of things you can do in that language. But after that, it's happening. And you can see that frameworks like Google Guava, they enforce formatting. And that is why we can use that as a good example to train the metrics and to get reasonable examples or reasonable results out of that. The question.
How did you come up with the 21 features? Is that the feature wizardry or experience?
Terence thought that's a good idea because that's all the information that you have out of the grammar. So that's 21. To be honest, in that example, we have one more. So it cares about the length of an identifier, and depending on that, it can make decisions. But yeah, 21 is the number that Terence came up because that is the amount of stuff that you get out of the grammar. So far from Codebuff, now the interesting part.
Yeah, let's come to the hot stuff. We see we need an AND grammar or some workarounds, so we don't have an AND grammar for each language, so it's not really language independent. And do we want to write an AND grammar to have a formatter? I don't think so. So there has to be another way. We all hear what Google, Facebook, or all the great big companies do with machine learning, so there has to be another way. So I think starting at the beginning, what is machine learning? Machine learning enables a machine to learn like a biological organism. So it has to learn to format like we format and how we do it. We don't look at the AST or on the grammar or what's everything what works behind. We look at the code. We decide on the code. We see a curly braces which opens a method. So we do a new line and an indentation. We see a point. It's concat the methods, so we do no white spaces. We have a semicolon at the end of a line, at the end of a command, so we do a new line and a line. Seems to work. So easy it is not. Semicolon, if you look in a for declaration, you need a space, not a new line. The closing curly braces describe that the outend has to be done before and not behind. So we need more informations. We need information about the next token, like the curly braces, so that it can override the formatting. And we need information about the context, the token we want to decide which white space belongs to. It stands in, like the for context. So, and furthermore, some knowledge about the language itself helps to which keywords exist, which operator and separator. Strings and comments should not be formatted because it's fluent text and it can be tricky. So, which technology we will use? So many machine learning algorithms. The k-nearest neighbor from Codebuff, a decision tree, support vector machines, deep learning. Yeah, we decide to use deep learning because at the moment everybody does it, and it seems really cool. And so what we will put in this neural network, we use an input of 25 tokens before and the current token, that's all. For training we need the white space, which is in between of the 25 token before and the token itself. This is during training, it's checked if it's the right, and if it's not, the network will be updated. And the output is a white space which stands in between. So this problem with the token behind, we solved because we use the white space before the current token, and so you can get all white spaces too. This is a workflow, so to say. We have a token like public or int or every other word in the language itself. This gets a numerical representation. The numerical representation has to become in a vector, and this vector is used as an input of the neural network. Then many magic, a black box happens, and at the end there is one of these 8 outputs which describe if a space is set, an alignment, a new line, or what we need. This is a picture of the neural network. It's shortened because otherwise the presentation would explode. I will step over, it's not good to talk about it. This is the problem in machine learning. We train with a set of training data, and the network can overfit on this training data. So it only knows this style. when you look at formatting. But what the problem can be if a change in the language, new syntax or something like this, how the network will get it. So we use a technique which is called early stopping. This you do during the training. If the training set accuracy will ever rise until it gets near 100%. But another test set from the same set of language of files can get to the 0% after a time, because it's overfit on the training stage. So we look when the test set goes down and there is a cut. And this network we will use. So the workflow to format something is to tokenize the complete source code, then train the network, then you can put something in the network, let predict, use these predictions to format. The training process has to be done once, and afterwards it can be stepped over. Some statistics to the neural network. It seems fine. Guava, like we see in Codebuff, really performs really good with 98%. But we see you need 2 hours, 3 hours, 1 hour. It takes a lot of time to train these networks, but you only have to do it once. Afterward, you have the network, you use it, and you will see afterwards how fast it can format. That's another statistic. It's a confusion matrix of the Guava. You see the red columns. These are bad. These are too high. All the diagonal values have to be high, because these are the values we want to get, and all others which are too high are marked red. So let's try this network out. At the moment, it's not so cool. We don't can format like in Eclipse. It's only in prototype, so we have to execute.
But it just takes a file and formats a string and stores that back. So it's the same approach with Codebuff. So putting that together with Eclipse shouldn't be a no-brainer.
Here we have an unformatted file. It's a Java file, and my network is saved here. And then the formatter loads the graph and format and write it to another file, so we can see it's ready, formatted. At the end, it seems like this. We see the class, the static void main, everything is formatted like we want. The comment gets a little bit indented, but this is something which has to be optimized in the network, which is a real long process, which we will done in the future, maybe next year. Part 3, we see the network performs on a complete file. Yeah. Back to the slides. The pro and con. The pro of the network, it is language independent. You don't have to, we have a prototype which calculates on the characters, so you even need any information about the language. The high accuracy is a pro and a con on both sides, because most networks are not trained over 95% because you want to be flexible to new data. The network is stored and can be reused how often you want. You need only a little set of information of the language or no. And the con, on the other hand, you need a long time to train. And at the moment, it's only one output per prediction. So you can't say do 2 spaces, make 1 space. To optimize the network, to get it faster trained, there exists transfer learning. Transfer learning, we see here a dog and a cat. The networks are used for predict pictures. So at the beginning, cats and dogs have many equality. They have 4 legs. They have 2 ears, 2 eyes, and everything. These parts can be reused in the next training if you want to switch from dogs to cats. The specific parts of cats, then you cut off the network, put in a new network and train new. In my network it would cut off the last layer, the token layer, because the layer before looks for the context of the token. Is it in a for context, is it in an if context or something like this? Put in a new token layer, train new, and you can switch from one Java style to the next Java style. Yeah, Codebuff against deep learning. The first thing I want to say is if you compare apple and orange, both are fruits, both are machine learning formatters, but at the end they complete on other ways. The first is a complete workflow between both. The input and Codebuff uses the AND grammar, the tokens of the grammar. The deep learning network uses the language itself, the words. The processing of both and which output comes. Codebuff tells, okay, you have this word comes at position at line 3, column 8, which is calculated from the token before. The network puts out do a space. The time to change from one style to another style is at the network really high. Codebuff train every time it format, so it's very flexible. The network you train once, you put it in the company or somewhere else in a project, and they can use ever and ever again. They don't have training time anymore. The precision of both we see in the network. The hello world gets at some points indentations which should not be there. Codebuff is more precise. So at the end, the main question is, what is the right way? Is a formatter which learns through machine learning, is this a right way? Because machine learning is at the moment machine learning performs not at 100%. It is nobody wants to 100% because you come at a point when you get new data, new structures or something like that, where you can get problems with 100% precision on the sets, on the data before. So I think everybody has to look for what is is state the best way and decide.
I mean, Codebuff is very pragmatic. It works, it's fast, and yeah, the calculation of the whole matrix takes milliseconds, and you don't need so many examples. I think that's cool. but still it's not perfect. It cannot be perfect. It has a precision of 95%, so that's something around that. That's okay. If you can live with that, Codebuff is something you can go with, but I think implementing a formatter is better. It's more deterministic, and especially when it comes to white space aware languages, you don't want to have a precision of 95, you want to have a precision of 100. Otherwise, it doesn't really conform to your grammar. So, and the approach from Fabio, I think the way of doing that is very interesting, but not really relevant. I mean, you will not use that for production thing. And with that said, we have 5 minutes for questions. Yes?
Is this approach also working for optional content in the grammars?
Which one?
The formatting approach.
Which one? Codebuff?
Both, of course.
For optional things.
Yeah, like I have opening and closing curly braces and optional content in it.
Okay.
So something can appear or not.
Question is, does that approach, we don't know which one, will work with optional things in the grammar? Yes, because it depends on the examples. If you have examples that leave that out, it will work. If you have examples that have that in, it will work. The approach cannot guarantee that it does it in a deterministic way, but it can handle it. So Terence, with Codebuff, tried it with a lot of different languages, with a big base of examples. And the best things came out by using Google Guava, because they are enforcing formatting. Others don't do that. Personally, I've tried to dig all the extent code out of the Xtext codebase. And to be honest, we do not predict formatting. We do not enforce formatting for those artifacts. And that is why the formatter that comes out of Codebuff is a mess. So it depends on the examples. Another question.
When you say that you don't need to have a grammar, like an AND-like grammar, to do this with machine learning in your way, your approach, but you still need to have a tokenizer to pre-process the input, or can you say, okay, a token is just a character?
At the moment, you need a preprocessor because neural networks don't work on words; they work with numerical values. So you have to tokenize the words of the language in numerical representations. If you use if you define keywords and all these things, you help the network because a keyword has another weight in the language than a normal variable name. And there's another idea to process on characters itself, so you don't need all this information. So you walk over the language and you put in A is 1, B is 2, and so on.
So it's possible?
It's possible, yes.
And he did already try that out.
And it works fine. Not as fine as a token variant because it's more variable, but from 90 to 95% precision you get, yes.
Your example, in a neural network example, you had a very small file. I mean, you have 25 tokens, as far as I could see, as input for a neural network. That means if you are in a loop or in curly braces with more than 25 tokens inside, you don't know that you are inside a curly brace. So
you do not need to know that you are in the curly brace. You need to see the next curly brace when it closes, because then you do the outline. The whole time you are in the in the curly brace, you can only do a line, so you can use the alignment of the line before.
I think we have time for one more question.
My question is very similar to
Sorry. Time reasons.
Also one more question. Similar to the last one, based on that, you were mentioning that some if you know that you're in a for loop or in an if loop, does it mean that you consider AST elements as context as well? But did you have a look at that? And
no, I don't use at any point the AST. I only use the words which are written in the code.
Yes, okay. So far you did not use the AST, and so far you did not use tokens after the one that you was looking at. Did you try to see the effect if you would look at these additional features, or
what the network does in the layers? I can't say it's a black box. This is a reason why I put 25 tokens in it, so the network can decide on its own what it has to be done to to get the right white space. All layers which are in the network, you don't know what they do.
It's more or less.
This is magic.
Let's take this offline because somehow I disconnected.
Maybe I did not really follow all of the things that he did in his master thesis. I mean, that's part of his master thesis. But for me, saying that in a very simple way is the network is training in asking if this is correct, no, oh damn. This is correct, no, damn. And then it learns what is correct and what is not correct, more or less.
It's not correct, damn, I have to done it in another way. It's more reinforcement learning, this is supervised learning, but...
Just wanted to say he doesn't have a grammar. And we have that in Codebuff, so that we have all the features, and that is why it's easier. But yeah, you understand. Okay, thanks for being here. Enjoy the rest of the conference, and of course.